Good morning, everyone. Today we will be taking a closer look at the periodic table of elements and the impact it has had on our understanding of the different chemical elements and their properties. We will discuss how Dmitry Mendeleev developed the periodic table, how it is organized with atomic number and its division into periods and groups. Dmitry Mendeleev developed the periodic table of elements in the 19th century as a tool for understanding the behavior of different chemical elements. It is based on the atomic number and properties of each element. Mendeleev noted the atomic weights, reactivity, and other chemical characteristics of known elements, and organized them in a table based on their atomic number, revealing the periodic repetition of their properties. This discovery paved the way for modern understanding of the behavior of different elements. The periodic table is a cornerstone of chemistry, having been established in the late 19th century. It provides us with a convenient system for ordering and categorizing the known chemical elements based on their atomic number. As such, it is a valuable resource not only for identification purposes, but also for understanding the chemical and physical attributes of the elements and how they interact in different reactions. The atomic number of an element is an important factor, as it gives us an indication of the element's general properties and can be used to predict its behavior in chemical reactions. All in all, the periodic table is an important tool for chemists and can help us to better understand the behavior of elements and their interaction with each other. The periodic table provides an organized view of elements and their atomic number and properties. It is comprised of periods and groups, which give an indication of an element's energy levels and valence electrons respectively. This structure allows us to gain a better understanding of the characteristics and behavior of elements. With this knowledge of atomic number and properties, we can now continue to the next slide. The periodic table is a powerful instrument in comprehending the characteristics and behavior of varied elements. Grouping and analyzing elements through their atomic numbers helps with perceiving their behavior and attributes. Exploring the table can give us knowledge of priceless principles of chemistry and physics, which are imperative for understanding the physical world. The periodic law is a cornerstone of chemistry, offering an understanding of the atomic structure and enabling the discovery of patterns and trends in the arrangement of chemical elements according to their atomic number and related properties. The periodic table organizes elements based on their atomic number and properties, and 4 distinctive groups can be found within it: alkaline metals, alkaline earth metals, transition metals and halogens. Alkali metals are highly reactive and located in Group 1. Transition metals have a variety of oxidation states and can be found in Groups 3 to 12. Alkaline earth metals are less reactive than alkali metals and have higher melting points, found in Group 2, and halogens found in Group 17 are highly reactive nonmetals that have a tendency to form salts with metals. These 4 groups of elements play an integral part in our understanding of chemistry. Valence electrons play an essential role in the chemical reactivity of elements and in their arrangement in the periodic table. The number of these electrons in the outermost shell of elements dictates how the elements interact with each other, which in turn affects the reactivity of the element. Through understanding the individual properties of elements and the role of their valence electron, scientists can place them in the correct order in the periodic table. Atomic structure is a crucial factor in the arrangement of elements in the periodic table. Electronegativity, which is the capacity of an atom to draw electrons, varies across the periodic table. Similarly, ionization energy, which is the energy needed to separate an electron from a neutral atom, also varies across the periodic table. Atomic radius, which is the size of an atom, likewise varies in accordance with the element and its location in the periodic table. All these properties are of great importance in how elements are ordered in the periodic table. The periodic table, first developed by Russian chemist Dmitry Mendeleev in 1869, is an invaluable tool in the study of chemistry and material science. It provides an organized arrangement of chemical elements based on their atomic number and properties. This structure reveals periodic patterns and properties that can be seen as you scan across the table. Certain elements share similar properties and are grouped together, while the properties of elements change across the table. By understanding these patterns and properties, we gain a deeper knowledge of the elements and how they interact with one another. The periodic table is a crucial part of understanding the nature of the chemical element. The periodic table is an essential tool in comprehending the characteristics and behavior of chemical elements. It is a well-structured system of all chemical elements depending on their atomic number and attributes. This composition gives a distinct structure for forecasting features of elements. It is divided into columns and rows where components are grouped depending on the number of protons in their atoms and shared properties. This permits us to make guesses about behavior and attributes of elements. The periodic table is an incredibly important tool in understanding the behavior of elements. It offers a great way to envisage and assess how elements interact with each other, arranged according to their atomic number and properties. This setup also allows us to appreciate the progress of the periodic table as new elements are discovered and included. By examining the periodic table, scientists can recognize the patterns in element properties and analyze how elements are linked to each other. This knowledge can provide scientists with new notions and lead to more discoveries. The periodic table is a priceless resource in our venture to comprehend the secrets of the universe. Chemistry is partly reliant on the periodic table to comprehend the composition of the natural world. It gives us a valuable structure to better understand distinct chemical elements according to their atomic number and characteristics. This framework is added to by the presence of isotope variations of a certain chemical element. Every isotope carries the same number of protons, but might differ in the number of neutrons, which leads to distinctions in its atomic mass. This can then result in varied physical attributes and behaviors. Exploring the periodic table helps us have a deeper understanding of the arrangement of elements and the consequences of isotopes on the atomic mass of elements. The periodic table is an extremely useful tool for comprehending the behavior of elements. It provides an organized manner of exploring the connections between the chemical qualities of elements and their atomic number. The table can be used to comprehend chemical reactions, bonding, and different attributes of the elements. It has influenced a variety of scientific areas, including physics, biology, and material science. This helpful structure offers great understanding into the behavior of the elements, making it an important part of the scientific understanding of the universe. The periodic table is a highly useful resource for comprehending the features of elements and how they collaborate with each other. It is employed to devise novel materials, manufacture pharmaceuticals, and fabricate modern products in numerous fields, including pharmaceutics, farming, and fabrication. With a set-up structure for the elements, we can utilize the periodic table to probe and spot novel chemical elements and inspect how they can be employed in day-to-day life. The periodic table is a powerful tool for understanding the behavior of elements, offering a unique perspective into the organization of elements based on their atomic number and properties. However, the periodic table also has its challenges and limitations, from gaps in the table to predicting properties for undiscovered elements. The periodic table continually raises questions for scientists to explore. Thank you all for listening and for your interest in the periodic table.